Hello, thank you for coming. As Robert said, my talk is Macros in Elixir, Responsible Code Generation. So just to tell you a little bit about where I work, before I start, I work at Brex. We are building B2B financial products. We have 2 products right now, cash and card. I particularly work on the systems team, which means I'm working with libraries, frameworks, and tooling, sort of building tools that product teams use to do their daily development. So a little bit about the talk. We're going to go over our goals, some basics, 3 examples, do a review, and then go over some questions if you have any. Let's get started. Why are we trying to write macros, right? Well, we would like to use macros to reduce boilerplate, enforce best practices, and improve reliability. But we would like to do this while keeping code readable, maintainable, and idiomatic, right? It's kind of like we're walking a tightrope. And if you don't, your code, macros used the wrong way, could become unreadable, your code could become unmaintainable and unidiomatic, right? So that's what we're trying to avoid. What is a macro? A macro is a transformation from AST to AST that is evaluated, expanded, at compile time, or in simple terms, it's code that writes code. And macros are all around us. So a lot of the constructs you see in Elixir every day are actually macros under the hood, like unless, if, def struct, pipe, and many more. And sort of really macros are doing the work to create a lot of the syntactic sugar that exists in Elixir. What's an AST? I mentioned it previously, but an AST is an abstract syntax tree. It is a step along the way of compiling Elixir. So Elixir is turned into this tree format that we do a lot of passes on, and then eventually we get to bytecode. And what's interesting about the Elixir AST is that it is a first-class value in Elixir. So it means you can write the AST in Elixir, the AST of Elixir in Elixir. And the structure of the AST is a 3-element tuple. The first element is the operator, the second is the metadata, and the third is the argument list. So let's look at some examples. 2 plus 3, starting simple. On the left is what is 2 plus 3, and on the right is the abstract syntax tree. You can see that the atom plus is the operator. There's some metadata information in the list, and then the arguments to plus 2 and 3. To get a little more complicated, what is the AST of a module? So I commented out, hid the metadata because it was getting pretty long, but you can see it is the same 3-element tuple structure, just expanded, goes deeper in the argument list. So for a module, there's a do block, then you get a function definition with another block, and eventually you get down to the same expression we saw before, the plus operator and x and y as arguments. Let's go over the anatomy of defining a macro in Elixir. This is what it looks like. There are 2 parts of the code that you need to be aware of. There's the code evaluated at compile time and the code that you are injecting into your caller's context. So things to be aware of, is that the code evaluated at compile time could be any code at all. So you could start gen servers, you could have agents, and imagine this is all happening at compile time. So if you're doing some dangerous or some non-deterministic stuff, you could really increase your compile times and maybe not compile at all. And then the code injected into the caller's context is totally unchecked. So there's nothing there to validate that what you're injecting is like right and reasonable code, or that if it's even valid in its structure at all. Quoted values and macro expansion. So macros are expanded from the outside in and recursively. So let's go over an example. You can do this in IEX yourself by using macro expand once, but here we have a simple if statement. If not, what's happening? Sorry. I think my slides got a little messed up, but we'll see how it goes. Here's the could be anything unchecked. Let's skip to quoted values. We'll get back to macro expansion in a little bit. So macros go from abstract syntax tree to abstract syntax tree. Quotes go from regular code to the abstract syntax tree, and unquote goes from AST to regular code. So we're going to play a little game. Here on the left, we have a macro, and I'm going to have you guess the value. So for X, what is your guess, code or AST? AST. What about unquote X? It's code. Unquote X plus unquote X. Oh, some mixed answers. Code. And then this whole quote block, AST. Nice. So one thing to be careful of is that when you unquote, you are evaluating the value that you are unquoting. So here in this example, I'm passing to double an IOInspect call. Note that when the arguments of a macro are not evaluated when you pass arguments to a macro. However, when you unquote, they are evaluated. So here, since I'm unquoting twice in the quote block, I see the side effect twice. One way to avoid that is to just unquote once and bind to a variable in your quote block. Elixir provides some special syntax to do this. You can use bind quoted to do the same thing, so you don't have to write that bind unquote. Okay, we're back to macro expansion. So if we start with unless, the first expansion goes to if not, which was on the other slide a little while ago. And then the second expansion goes to case not, do this big case statement. And so this is how, when a macro is being expanded at compile time to figure out what code should eventually be injected, it will go through this process saying, is there a macro in my code? Yes, go deeper. Yes, go deeper, until you get to a place where there's no more macros. Contexts. So I was talking about caller context and macro context a little before, but there's really, you have to be aware of these two contexts. One is the macro context. That's happening before the quote block. And then the stuff inside the quote block is happening in the caller's context. And I put the caller on, the right-hand side, maybe your left. So here we can see it with some IOInspects. If we print out underscore, underscore, module, underscore, underscore, when we are in the macro context, we print out my mod. But when we are in the caller context, we print out my caller, even though we are in the macros body for the whole thing. If we unquoted the value of the module of underscore, underscore, module while in the quote, we actually get my mod. So if we're trying to pull values from the macros context into the quote, we would use unquote. And then one more. So there's also this thing called macro env. It holds a struct that holds compile time environment information. You can access it using underscore, underscore, env, or you can access the caller's environment by doing underscore, underscore, caller. And doing that, you can also find out who your caller is and maybe what functions they define, et cetera. And that might all be useful when you are writing macros. Hygiene. So hygiene is making sure that the variables, imports, and aliases you have defined in your macro do not leak into the caller's own definitions. So here we have an example. Set is a macro that binds v, just binds the value val to v. But then when we go into IEX, we set v equal to 2, or we assign v to 2, then we call the set macro, but when we check the value of v, it's still 2. So the variables in the macro do not leak. But if you wanted to override this safety check, you can use var. I still haven't needed to use this function, so I'm not sure why you would want to do this. But you can but here you can see I assign v to 2, I override it to 3, and when I check the value of v, it's 3. Just to go over some special cases, so you probably see use around in your code base. Use is just some syntactic sugar. It's in the kernel special forms for writing require my module using. And all use does is it pulls in and executes the def macro using from whatever module you're using. So let's revisit our goals. We're trying to use macros to reduce boilerplate, enforce best practices, and improve performance and reliability, all while keeping code readable, maintainable, and idiomatic. We still want it to feel like Elixir, right? So we're really trying to strike this balance. Let's go into some examples. Struct definition. Defining a struct in Elixir is pretty easy. Here I'm doing it on one line. You just pass a list of fields, and then you're done. But say you want to add a few extra constraints. Maybe you have some fields that are required, so you use enforce keys. Maybe you have some defaults, so you pass them into def struct with these tuples. And then maybe the struct that you're defining is a public model, and you need to have some type information for documentation. You want to, say certain things about each field, so you're writing these like docs, and all of a sudden, it gets pretty long. So how can we make this better? Well, we could reduce boilerplate by referencing each field only once. Right now, we have to write the same field name in multiple places when defining structs. We could enforce best practices by making fields required by default. This is like being opinionated. And if you are going to have a field that's optional, you need to explicitly state a default. And we could improve reliability by validating at compile time, validating some stuff. So the next question I want you guys to ask yourselves when you're writing macros are, do we need a macro? Can this be done with behaviors and protocols? In this case, no. Can this be done with some clever use of higher order functions? Also, no in this case. And for this case in particular, are there functions that can produce a struct definition? And not to my knowledge in Elixir, right? It has to be done using def struct, not in a function. So we need a macro. This is what we came up with. It is for all intents and purposes, a DSL. You only specify each field once, and then if you have a default, you sort of write it as the fourth argument on the field line. And we have these field docs that sort of annotate each field. And what's cool about those is they are injected into automatically generated documentation. So if you ran like xdoc and generated the documentation for this struct, it would have these individual field docs as well as which fields are optional, which are required, what's their default, all like in the documentation lines. So how did we do this? It's a big block of code, but what's important is there are three main parts. There is parsing the fields. Then there is some code generation that takes place. And finally, there is injecting the code you want into the caller's context. So let's go over parsing. Again, a lot of code, but what's important to take away from this parsing chunk is that there are actually no macros in the parsing code. So it's all just happening by recursing the AST and building up a map. But there's nothing here that's like particularly, there's no macros. So it's just regular old Elixir code. Another thing that's nice about parsing is that while we're parsing, we can do some static validations. So here we're raising a argument error, and since this all is happening at compile time, this will become a compile time error. We are using the open source library Optimal to check keyword list types and to make sure like the flags that we want in the keyword list are there. So to give an example, say you write, we call it beatdef struct. You write a struct definition like this, but it's got some bad args and it has some field attributes that we haven't specified. Then when you compile, you'll get an argument error. And we did some nice, pretty printing, so it would say, hey, you used bad arg, that's not allowed. This macro only takes empty list, etc. So it will be very clear and useful, debuggable to your developers, right? You want to make sure that you are building with the person who is going to use this macro in mind. So if parsing was from the AST to a map, in CodeGen, we take the map of fields that we built and then we're generating an AST. So here is an example of just one part of when we're actually doing the def struct code generation. Essentially what we do is we go over the fields map, we just pull out the values we need. If it's required, just the atom. If it's not, take the default with it. And then we just inject the code, def struct with like the keyword list. For the injection part, my recommendation is to keep this part really small as possible, and to do most of your work outside of the quoted portion, and even outside of the macro if you can. So as I said, the quoted code is unchecked, and like writing ASTs by hand is really dangerous. You don't know if you will, get all of the syntax exactly right. So it's best to write it in regular Elixir code and then to check using macro validate, macro toString, and code eval quoted when you are writing your macro. So another example is schema definition. The structs, you could say, oh, it wasn't that many lines, it was okay. As we were defining schemas, we would have a 10-field schema that would eventually have 100 lines of code when it had all of the checks that we wanted, all of the change sets that basically looked the same across schemas. So we said, that's way too much. Is there a better way? Well, we could reduce boilerplate by again referencing each field only once and automatically generating the change set validations. We could enforce best practices by making sure that by saying that fields are immutable and required by default. What I mean by immutable is that once you insert into the database, you can't go and change that value. So if you want a field to be mutable, you have to specifically say so. And we could improve performance reliability by compile time validations. So we knew this would be a big sort of sweeping change in our code base, especially if we wanted a lot of adoption. So we said, well, how do we know if the abstraction we're picking is actually the right one? How do we know if we've been successful? So we set a goal for at least 50% lines of code reduction when you're defining schemas. We wanted 100% of new schemas that people were writing to use our construct. So we wanted really strong adoption. And then we were gauging how many questions were asked to really tell how much of our API was unintuitive and unclear. So were we building something that was really useful for people, or was it kind of heavy and burdensome? Maybe we made some wrong design decisions. This is what we came up with. You can annotate your fields. So instead of having to write a whole separate part to say a field is unique, or to write a whole validation to say this field is mutable versus immutable. You can just tag it, and everything will be generated for you. And when we were writing this, we didn't want our developers to have to go muddle around in the macro code and try to figure out exactly what we were generating. So we provided them with some contracts to make it clear exactly what the value proposition was. We said, if you use data schema, we will provide to you a change set function, a raw change set function, and a function validate params. So the change set function had all of the validations that we wanted on it. The raw change set function acted as sort of an escape hatch, whereas say you wanted just bare bones validations, and then we had this function validate params. In our code does nothing, but we made it def overridable, which meant that the user of our schema could go in, define their own validate params function, and then that would be called, as you can see, in our change set function. So they could easily extend the amount of validations that were happening without having to go in and, redo extra work or, change the generated code. We also provided some reflections. So these are functions that are not really meant for production use. They're sort of just for introspection, but they are pretty useful if you want to find out exactly what's happening. So we had this function fields, which would just return the fields, and macro arguments, which would somewhere return the arguments. They are underscored by convention because they're sort of secret and only there if you're really digging. And we used macro escape, which means if you have a piece of code that maybe already has an AST in it, then unquoting it gets difficult, so you have to escape the AST first in order to unquote. And the reflections actually became very useful to us. Here's a lot of code, but essentially we were able to generate the ecto migration from the schema via a mix task by just calling our reflection functions. So here I have an example. If you have this data schema on the left-hand side, then if you ran this mix task that we made above, which is some of this code, then it would automatically generate the migration, and it would also create some of the indexes that we sort of knew you would need. Like if there's a belongs to, you probably want an index on that field. So again, we're making opinionated tools, but tools that hopefully really help the developer increase their speed and velocity. So looking at these two constructs, our struct definer and our schema definer, they look pretty similar, right? Their shape is almost the same. And so we said, really, if we wanted to boil it down, this is what's happening. There's a macro name, some arguments, and then field keywords with some arguments, and then you can tag the fields with some field attributes. So we need to go deeper. We need a meta macro. Wow. Why a meta macro? Well, instead of having to write these big, complex macros over and over again, especially if we wanted to have more schema-shaped objects, now it would become easy to define these schemas. Also, they would become easily extendable. So, for example, we thought, what if we wanted to add another field attribute, which let us specify if a field is like JSON encodable or something? Then we could add that easily. And of course, with a meta macro, Brex struct and Brex data schema become macroless. So it's sort of like defining another DSL, but because we're doing that, then it becomes very easy to define your macros. So how did we do it? we said, okay, if you're trying to write one of these schema-like macros, you have to define these 6 things. Process fields is just like a hook at the end of the parser if you wanted to mess with the parsing map before it goes to code gen. And then you have to define your code gen function, which takes in whatever arguments people are passing to the macro and the fields, and then actually generates an AST that you want to inject. And then you also had to tell us, well, what was your macro name? What's the types of arguments it accepts? What are the keywords? And what are the attributes? So I have an example. So for BDEF struct, you can see it's pretty simple. It takes no arguments. And this way of specifying type is specific to Optimal. So it's like a little verbose. Optimal, the open source library we're using, but it works for us because not that many people see this code. Field keywords, just field. Field attributes, field doc. Of course, for the schema definition, we have a ton more arguments, a ton more field keywords because you need all of the ecto, like belongs to many, etc. But yeah, by just defining these and then defining those 2 plain old functions, we were able to produce, to give these things in return. So we promise to return 2 reflection functions, fields and macro arguments, and then we also generate the macro that you are hoping to have. A key feature that we needed to understand were module attributes. So in the Getting Started guide, it says module attributes in Elixir serve 3 purposes: to annotate the module, to work as constants, and to work as temporary module storage to be used during compilation. That's what we're using module attributes for in this meta macro definition. So after a module is compiled, you cannot access its module attributes. So we have to access the module attributes, the Brex struct and Brex data schema before they're compiled. So just to clarify, module attributes are like these things. But of course, there is some compilation race conditions here because you need Brex struct and Brex data schema not to be compiled yet, but you do need their files to be like open, and you need to have read the module attributes. So you're facing some race conditions, and so we needed a way to force compilation order. So Elixir provides 2 ways. There are before compile and after compile. Of course, you can get yourself into sort of a bind with deadlocks if you're not careful. Again, this is a lot of code, but this is saying, hey, please, before data schema is compiled, please execute the before compile hook defined in meta macro so that you can grab the module attributes and do this code injection. So testing. How do we know if any of this works? Right? Chris McCord, metaprogramming expert, wrote a book. Says, test your generated code, not your code generation. That's a sentiment I really agree with. So what I did is I just wrote a bunch of different types of data schemas and a bunch of different struct definitions and sort of tested all edge cases. It makes it so that you don't have to do some like weird AST validations in your tests. You're just sort of checking, in the end, does this work and does this do what I want it to do? So let's revisit our goals one more time. Did we reduce boilerplate? Well, I think we did. Defining structs and schemas takes 50% less code, and defining those macros also takes less code. Did we enforce best practices? So we had our fields be required and immutable by default. For the schemas, we were auto-generating a lot of validations, and we were also validating on parsing. And did we improve reliability? So yes, by some compile time checks and optimizations, you didn't have bugs in your runtime code because you were catching them at compile time. Is our code readable? Well, I would say this is a thoughtful and well-documented DSL. Is it maintainable? So we can add field attributes as we want to our schemas. And most of the code we wrote is outside of a macro, which means that regular Elixir developers can come and read it and not be afraid of it. And then is it idiomatic? Well, instead of having sort of a macro that exists everywhere in your code, this DSL has limited scope. So we're only using these DSLs in schema definition and struct definition, not like, in everyday service code. We didn't overload any built-ins, so, we didn't overload def struct because that's always a little risky. You don't know, you have to be very careful. And we didn't, instead of just like saying whatever def struct, we'll build our own, we built on top of it. So our code then calls def struct. So we didn't like reinvent the wheel, right? We used the tools that were already there. This is what we covered. It's a lot of topics. But I think hopefully you sort of have a handle on what you need to go write your first macros. Some resources. The syntactic reference for Elixir is excellent. Any like syntactic sugar you might see around and you're like, wow, why are there like 3 different ways to write keyword lists? The syntactic reference makes it very clear what is equivalent and what isn't. Optimal, great validations library. Most of the code, the functions I was calling are just from regular Elixir modules, so like kernel, macro, code, and module. And of course, the metaprogramming Elixir book has a lot of concrete macro examples, and it's really good for like hitting the ground running and starting to write macros. Any questions? The mic.
Nope. Can we turn this on? Yeah. Is it working? Yes. So we have questions. Okay, we'll start down the middle, then we'll move around.
So your Ecto schema wrapper is awesome, and I wish I had it because I would have saved a lot of code. So do you all have any plans of open sourcing that at any point, bringing it up to the community? Seems like you've talked about it.
Yeah, we've definitely talked about it. I think we're mixed on how much of our opinions we want to like enforce on the world, but and it's actually not that much code to just write yourself, so I encourage you to go write like the 2 modules it takes. But yeah, I think we just kind of have to strip some of the Brexisms from it, and then could totally make it open source. We have thought about it.
Yeah, I've thought about doing the same thing. It just didn't go through the effort of it.
So did you meet your goal of getting 100% usage compliance?
Yeah, honestly, we even had people convert old schemas to our new schema construct. We're sort of in a place in the company where we can still mandate those things and sort of lay down the hammer. But no, people like it. People really like using data schema because it's less work for them. So, and it's like we wrote lots of documentation so people aren't confused to what's happening. So.
Okay, any more questions? Nope. Okay, thanks again, Lizzie.
Thank you.